report looks at the feasibility of the project from a number of different perspectives. Typically, those perspectives are that it can be done within the funding limits of the authority, and there are caps, funding caps on cap projects, whether the project is engineeringly feasible, and whether the non-federal sponsor has the funding for the funding match. Additionally, the project typically has to meet a cost-benefit analysis ratio of at least 1-to-1. So the project has to be either saving infrastructure damage, preventing damage, or provide ecological benefits to the extent that the project achieves that 1-to-1 ratio. It's easier when you're mitigating a damage issue, but we also have a number of sections that have projects with ecological benefits that over a base of a non-project condition, what would the benefits be if an ecological project was built? And that's how that's quantified through our modeling. The third bullet goes to the issue of the feasibility cost share agreement. Typically, these projects have somewhat standard cost sharing agreements, but that is put in place up front. And with that signed, a feasibility study kicks off with an integrated environmental assessment. The typical time frame to complete as it's called, a detailed project report is 24 months, depending on the complexity of the project. Cost share for the first $100,000 is 100% federal, and above that is 50% federal and 50% non-federal cost share. And that is pretty standard across the board for all sections. Additionally, a project partnership agreement, or a PPA, is developed and signed, and it defines the federal and non-federal contributions to the project, both in kind and cash. And sometimes these in-kind services could be credits for land, easements, rights-of-way, or relocations, which is another core acronym called LERRDS, L-E-R-R-D-S. It also defines the long-term operational and maintenance responsibilities. Cost share varies by the cap authority section, and is anywhere from 25% to 90% federal funding. More than often, it's 65% federal, 35% non-federal. And typically, all operation, maintenance, repair of the project in the future is at 100% non-federal costs. There are a couple that are 100% federal costs, and we'll see which ones those are with the next slides. The first section is Section 14, which is stream bank and shoreline protection of the 1946 Flood Control Act as amended. And an example of a project was Ottawa River in Toledo, Ohio. It was about 2,200 feet of stream bank stabilization along a road, Shoreland Avenue. The bank was being undercut by the water by the Ottawa River. It was towed, meaning given support on the bottom, and then rip-wrapped with large stone to support the bank, and then seeded in between. Additionally to the project, what they added were stone groins to enhance fish habitat. If you're not familiar with what groins are in these types of projects, it's a sort of a little jetty, a little rocks that stick out from the bank that give fish an area to rest during high water flows so they continue their spawning runs. It also, depending on the size, can give them actually a place to spawn. So there was in addition to the stream bank protection, there was an environmental enhancement with this project also. As you can see, the before and after photos, they're a little difficult to see because of the size, but basically it was rip wrapped and seeded. But this is where the 1-to-1 ratio comes in. You can see that there's a car on top of that bank, so there's public infrastructure at the very top of the project. Should that have continued the way it was without any sort of mitigation of the erosion, the value of the road and any utilities, either under the road or alongside the road, could have been lost. So those assets help make the BC ratio, the benefit cost ratios. The scope of this project, had highways, bridge approaches, public works, any of these sorts of public assets that are in danger could be used to move that benefit cost ratio and get it to the 1-to-1 ratio. So again, as I said on the previous slide, pretty standard is the first $100,000 is 100% federal and further is 50-50. And as I said previously, this is the typical cost share on Section 14 projects is 65 federal, 35 non-federal. So on Section 14 projects, I'm going back to what I had said previously, that the first 4 and now the first 5 are all standard as that typical CAP project slide said. The design, again, is a 65-35, 65 federal, 35 non-federal. Oops, I'm sorry. And the project at its completion, all the O&M will fall back to the non-federal sponsor. And that is typical, except for, as we'll see, I think CAP 107s with federal navigation channels. Hurricane and storm damage reduction. With high lake levels, both in Ontario and Erie, the potential, and I'm sort of socializing this right now with heavy infrastructure, public infrastructure along the lake shores to see if there are issues. One of the projects that came up was the restoring about 1,300 feet of concrete seawall along LaSalle Park, directly in front of the Ward pumping station that had deteriorated over the last 50 years. The infrastructure that made this project a go was the pumping station, the filtration plant, parkland, and an access road. So there was a lot of infrastructure that if this wall were to fail, it would be subject to almost full lake wave heights, and it would have eaten back the shoreline fairly quickly. So this project is moving forward. There is a federal cap on these projects of $10 million for Section 103s. So with the cost share, it's the 65-35, the project's total with federal and non-federal funding can move just around in the ballpark of a $13 million project for an overall total project cost if required. Again, the feasibility on these is 100% federal and then shared 50-50 after that first 100,000. And design and construction costs are 65-35, federal, non-federal, for hurricane and storm damage projects. And then for recreational beach projects, it's a different ratio of 50-50. So as I'll say again, the first 5 are the same as far as the project timeline or functional timeline. And as I just said, 65-35 for hurricane and storm damage projects and 50-50 for recreational beach projects. And operation and maintenance into the future is a 100% non-federal cost. Navigation, Section 107 is, at least in this project, is a harbor deepening. I'm actually working on one of these projects in Oswego, New York. These can be used to deepen the harbors. A lot of the modern lake freighter fleets require a 27-foot depth because of their draft or how deep the vessel can go fully loaded. So deepening the harbors is something that makes them more economically viable because they can move more tonnage of commodities or material in one harbor movement, as it's called. So these projects, again, are limited to $10 million. The study costs are, again, $100,000 and 50-50. And commercial navigation projects are a little different. The cost can range from 10 to 50%. Recreation are 50% non-federal, and the reason there's a range is because it depends on the depth that it's dredged to, and there's a formula that goes along with that I won't bore you with, but that's why there's a variation in the non-federal costs because of those different dredging depths and what Congress has authorized as the depth for a harbor. The Congress and through different water resource development acts have set the dredging depth for all the harbors within the United States and territories. And these typically can only be changed by an act of Congress. But this section allows for, I should say, required an act of Congress in the past. But now this section allows for deepening of harbors without, again, having to go back to Congress for a congressional act to do that, which is much more efficient. Timeline, or I should say the functional, is the first five are the same again. Design and construction, again, that range based on depth. And these projects, all maintenance and dredging in the future is 100% federal cost. So this is the one that I was talking about that was different on the O&M side because of the national interest in maintaining commerce and any navigation channels that may have any military significance. Section 111, mitigation of shoreline erosion damage caused by federal navigation projects. This is what I alluded to up front, that if a federal project was built at any time in the past and it's now causing issues, this allows the Corps to come back in and try to alleviate those issues. Half Moon Bay, California, beach fill to mitigate bluff erosion. Since the construction of a breakwater, sometimes these things weren't anticipated back when they were built, that these problems would occur, but this section gives the vehicle to be able to rectify those. Again, it's limited to a cost of federal participation of $10 million. Study costs, again, the typical. And the cost sharing is at the same proportion, this is different than the standard. Cost sharing is at the same proportion as the original federal project causing the shore damage for this project, at least. And work beyond that is directly attributed to the federal navigation project is 100% federal. So that is a little bit different of a design and construction cost share. Again, the first 5 are standard. The design and construction cost share is what I just said previous. And the operation and maintenance for OMR, R, and R, which is operation, maintenance, repair, rehabilitation, and replacement, is at 100% federal cost. Regional sediment management is a section 204 of the award of 1992. Provides for the protection, restoration, and creation of aquatic and ecologically related habitats, or to reduce storm damage to property in connection with dredging and construction of operation and maintenance of federal navigation projects. And again, it's limited to $10 million. I've managed a couple of these projects already. Essentially, it's using dredge material to create wildlife habitat and or protect shoreline. Usually revolves around shallowing the water with the dredged material as to give spawning areas and more shallow areas for species to provide a food source for fisheries. Typically, and most of you probably know this already, but deeper waters, because of lack of sunlight and other factors, really don't provide a species richness or diversity. Using this material, usually behind some sort of structure to hold it in place, shallows the water to make a habitat zone for food source species for fisheries. So these are, and it provides a way to utilize dredge material, which in most cases, for most of the ports in New York and Pennsylvania and Ohio, is a very silty, typically fine sands and clays, which really, it's tough to find a purpose for it because it has no structural stability for fill or any other means. It when wet, it's sort of it liquefies. So this provides a use for those materials that typically are placed in the open lake in deep water and really have their benign materials, being the constituents that I just mentioned. So they just sort of sink to the bottom and that's where they stay. But this gives I guess, some use for the material. And like I said, I worked on a few of these, and they've made, since we've lost about 90% of the wetlands on the Great Lakes, this is a material that can be used to, again, shallow the waters and potentially bring back a small portion of what was lost. And typically, if I haven't said already, the cost, federal cost limit is $10 million. Feasibility, the entire feasibility is 100% federal cost, as opposed to the first $100,000 being federal cost and then the rest being 50-50 with the non-federal sponsor. These are 100% federal, and design and construction is goes back to the typical 65-35 federal, non-federal. One of the projects is that we had done was Unity Island. The northernmost point of the island was a dredge disposal area, and the waters were deep enough that they were not being productive as a habitat. So, as you see in the before photo, it's just pretty much open water. The green areas here with channels allowing species to get up into the shallow areas easier was done, and it's already being colonized by different species and plants that are typical to marshland, wetland areas. This area right here, if you can see my cursor, is an inlet from the lake to allow some circulation so the water does not stagnate. And these are our offices right over here, so it's very, very close to us in a successful project. So I guess something to keep in mind if you are along the lake shore, if you have and want to do one of these projects, this is, although you probably have to have some sort of sheltering to keep the lake waves from tearing it apart, this was already surrounded by, like I said, a heavy stone dike, so it has no potential for any erosion or lake waves getting in there and destroying, or just, I'll say, sort of tearing up what was planted in there. I think there's 5 acres in there, and additionally there were some trees submerged in there to give some roughness and what was it called? Refugia for fish to shelter or hide from predators. So another locally successful project in Section 204. Again, what changes here is the 100% federal for the feasibility study. The design and construction is the typical 65-35, and the OMM&R is a 100% non-federal cost for these projects. Flood risk management, Section 205s. The example here is the Casnoga Creek ice control structure in West Seneca. Steel jacketed concrete piers, which you can sort of see here, were anchored into the bedrock to act as an ice retention barrier to reduce downstream ice jam flooding. Again, the scope, federal cost $10 million. Feasibility is 100% federal. Further study is 50-50 federal, non-federal, and design and construction is 65-35, with a minimum of 5% non-federal in cash. Another successful project. One thing that was found that it also acted as a trash rack. Trash, in this case, meaning trees that had fallen into the creek, other debris. So there was some modification to be able to reach those materials with a long reach grapple to pull them out to have them then ground up into mulch eventually. But this also is now serving a dual purpose for ice and a trash rack to keep things from flowing downstream and damming up and again causing flooding issues. 1 through 5 are the same. Design and construction here is an 18 to 30 month process, again at 65-35, and a 100% non-federal cost for OMRR and R. Aquatic ecosystem restoration, Section 206s. The example project is the Chautauqua Creek Dam in Westfield, New York. Oh, I'm sorry. I went too far. There we go. There was the remnants of a dam on Chautauqua Creek that was impeding fish spawning past it. They in the spring they just could not get past this impediment due to the flows or the actual structure. As you see, it's sort of I call it a kick-up dam base that's left, and there's no way a fish can get past that. And over here it's tall, and over here it's just brushed in. So to allow more of the creek to provide spawning area in the spring. It was decided that Westfield wanted to remove this impediment. Again, the cap is $10 million. The first $100,000, the feasibility is 100% federal cost, as are 204s. But further study is 50-50, federal, non-federal, and then there's the standard 65-35. Again, the first five are essentially the same, except for this. If you can see my cursor, it's what we just talked about. It was the matches. 65-35 in design and construction, and 100% is on the operation and maintenance is non-federal cost. Clearing and snagging, which is section 208. So I mentioned this a little bit off the get-go. One of the projects that was, I guess, a larger project was in Arkansas, maintaining a channel condition so that it would, the roughness of the brush would not impede flow. So as you see, the excavator with the chipper head attachment is essentially grinding down the trees onto stumps so that in a flood condition, these trees wouldn't impede flow, I guess, on this levee structure, which is down here with, I guess, most likely concrete panels. Again, it's for channel clearing and excavation, limited embankment construction, probably just some small reconstruction if there was anything damaged during the project. There's reduced flood damage caused by debris or minor shoaling of rivers. Feasibility is 100%. Costs over $100,000 or 50-50, and then a 55-35. With this, there's a minimum of non-federal cash. Again, the standard, what we just discussed, 1 through 5, 65-35, and again, that 5% non-federal cash and 100% non-federal costs for all MRR and R. Section 506s. These go along with the GLIFR program. This is Franklin Dam in Michigan. This was removal of the dam and construction of a rock ramp structure providing a 3% grade through the Cass River, allowing targeted species of lake sturgeon and walleye to make their way through here on spawning runs and potentially even spawning within the project. It's difficult to see, but there is a grade here. The dam was an obvious impediment to spawning, but with the grade, the flows here within the river were quick and an impediment to spawning. So these structures, rock sort of walls, so to speak, with a passage up through the center, allows fish to enter, and then if the flows are high, come into any one of these offshoots in between these walls and sort of work their way up through as their strength permits. And then that not only gives structure here on both sides also for flood damage control and erosion, but allows the fisheries to thrive and expand. Again, $10 million cap, 100,000 feasibility, at 100% federal cost, and then further study the 50-50, and then the 65-35 match. Again, all the same as we just talked, and then OMR is 100%. Section 1135, modifications to projects for improvement to the environment. It's, again, taking existing projects, I clicked again. Taking existing projects and making them more environmentally friendly, as they may not have been designed that way in the past. So, again, this is a weir on the 38th Street drop structure. I'm making an assumption because I didn't work on this project that essentially slows down flows, gives places for fish to rest before they make the attempt to get through the higher flowing area of the stream, and knocks down solid impediments that would prevent fish from making it up into higher spawning areas. $10 million scope, 100. First 100,000, 100%, and then 50-50. And these are a different share structure of 75-25. Control of sea lamprey, very, very important. And this is the section 506 and an 1135 together. There's currently a run on the river, but the prime contributor sea lamprey in the Great Lakes system. Project was to install a barrier to prevent upstream migration and remove 57 miles of spawning and nursery habitat for the lamprey, greatly reducing the need for lampricides. So this is actually flipping it the other way of not removing, but putting in a structure to prevent sea lamprey from getting up into spawning grounds and increasing their numbers. Typically, these things have a gate or something in there that allows fish to pass, but lamprey to not. So that you wouldn't be impeding fish spawning, but you would be impeding lamprey spawning. The first 100,000 is 100% federal and then 50-50, and this is, again, a little bit different ratio of 75-25. And, again, as we had just said, these are all 75-25 and 100%. Sorry for the repetition, but it's they go back and forth. Like I said, the CAP Authorities program provides the Corps, USAC, with the authority to solve water resource flood risk mitigation and environmental restoration problems in partnership with local sponsors without the need to obtain specific congressional authorization. CAP projects have two phases, the feasibility phase followed by the design and implementation phase. Just sort of an overall recap, no pun intended. Development of alternative plans. This is what happens in feasibility. Different alternatives are looked at. Cost estimates are made. Environmental analysis occurs, and real estate assessments are done for LERDs, which can be used for in-kind and federally funded up to $100,000. And the D&I phase includes final design, contract plans, all permitting, real estate acquisition, project contracting and construction, and activities related to implement the project. Non-federal sponsor costs can include cash, lands, easements, rights-of-way locations, and disposal areas, or work in kind. And when a project is completed, continued operation and maintenance is typically the responsibility of the non-federal sponsor. I will say that the projects that I've worked on have been larger projects that have pushed the federal cap to its limit. These are large projects, and like I said, they take sometimes up to 2 years to do the studies because of the complexity. And municipalities, if they have minor erosion issues, it's almost, whether it's lake shore or stream bank or river erosion, it's usually more efficient for them to, if it's an imminent issue of loss of infrastructure. Typically, like I said, our projects are larger. Not to say that we couldn't look at it, but our time frame for doing what we need to do with all the different factors that we take into account, like I said, it takes sometimes up to 24 months to do the report. So if there's an area that's an imminent danger, you'd most likely be better off tackling that yourself, at least to get it stabilized, and then potentially looking at a project with the Corps, because the projects typically take a 24-month time frame. I mean, I've sat in meetings where they say we have a municipality or an authority or a sewer district says, we need something to prevent this water main from, or this infrastructure from being destroyed, but it's not a big enough project to involve the Corps. But sometimes there. To request assistance, this is my direct supervisor's contact information. Joanna has my contact information, so if you have any questions on the presentation, or if you want to run some ideas past me, if there are projects that you're thinking of or know of, or can refer someone to me, she has that information. Project-specific fact sheets are at the URL that you see there, and upon receipt of a letter of request, we can determine if the project is a good fit for any of these sections, and if so, we can request funding to initiate the process to determine a federal interest study. So I guess with that, and I know you all have access to the presentation, or does anyone have any questions for me?